Our last strategy is permutations with cases. So we saw when we went over our homework that sometimes you can't count things all at once. It's impossible to do it in one step. So we use this strategy, permutations with cases, when you have to break things up into smaller, different examples, count them in those smaller examples, and add them up in the end. Here's an example where it says you want to use the digits 0 through 9. You're using different digits, so repetition is not allowed. But you can have at most 3 digits. So with at most 3 digits, well, that's 3-digit numbers, 2-digit numbers, and 1-digit numbers. And you can't count 1-digit numbers at the same time as counting 3-digit numbers, so this one makes sense to break up into different cases. When you have a cases question, as far as organizing your work, what you'll do is you'll start out by saying, this is what I'm deciding to make my first case. Case number 1, I'm going to count all my 3-digit numbers. Well, that's a spaces question. I'd have 3 decisions to make. What number is this? That's 92. Is that a 3-digit number or a 2-digit number? 2-digit number. So can you see that we also have within this question some restrictions? We have a restriction on our first digit. Our first digit can't be a 0, otherwise it would be a 2-digit number. So remember, when you have a restriction, you deal with that restriction first. How many choices would you have for this first number? 9. Because there's 10 digits in total, 1 through 9 plus 0. But we can't have 0 for the first digit, so we would have only 9 choices. But after you've chosen that first digit, there are no restrictions other than you can't repeat. So how many choices would you have for your second digit? 9. Because now you could add 0 back in, but you have to take out whatever number you chose first. And then how many choices would you have for your last digit? 8. You've used up 2 numbers, or 2 digits. You have 8 choices left. Multiply all these together. In the cases question, when you get to your second case or your next case, you always go, well, what haven't I counted yet? And we often try to do it in somewhat of a systematic way. So I've counted 3-digit numbers. Next, I'd like to count 2-digit numbers. Well, spaces, any restrictions? Yeah? Because the question says at most 3 different digits. So that could be a 3-digit number, it could be a 2-digit number, and it could be a single-digit number. So again, this one's not 0. This one, you put that number back in. You'd have 81 possibilities of 2-digit numbers. Case 3. And now we're going to have a discussion. Does 0 count? Is 0 a number? 0 is a number. I think people would say yes, 0 is a number. How many digits does it have when you write it? 1. Right? Because 0 is still a digit. So here you would have 10 choices. And then with cases, once you've counted your separate cases, to find out how many things there are in total, we just need to add everything up. So 648 plus 81 plus 10, 739. So this is one type of cases question. Here's another type of cases question. This is a type of cases question which deals with more than one restriction. So here we're using 1, 2, 3, 4, and 5, those digits. We're not allowed to repeat. And in addition to not allowing to repeat, we want the number to be greater than 300 and even. So you would start this, had you not been taught cases, or you haven't really been taught this yet, you would start this by putting, hey, I have 3 decisions to make. And I have some restrictions, so I will write my restrictions underneath. It needs to be greater than 300. Does that make sense that I need to start with a 3 or 4 or 5? And it needs to be even, which means I need to end with either the 2 or the 4. And you said before, well, we deal with our restrictions first. So how many choices do I have for this one? 3. How many choices do I have for this one? Always 2? Or sometimes 1? Because if I chose the 4 to begin with, then I don't have 2 choices here. But I don't know if I chose the 4 to begin with. So then I should have 2. Should I put like 1.5, but maybe I don't, you run into a problem. So we have a problem if we have a restrictions question and one of our restrictions overlaps. It's going to cause a problem because we won't know if we chose that or not, and then we won't know what to write in the end. So anytime you have a restrictions problem like this where one of your restrictions is causing problems overlapping with the other one, you're going to break it up into cases. So you choose one of your restrictions, and if I was choosing first, I'd probably pick my last restriction because it only has 2 choices. Okay, we'll do it with the other restriction as well, but I'm going to break things up to count it separately. So my case 1, I'm going to say, well, my 4 is causing me a problem. I'm going to end with a 4. I still have my 3 spaces, but case 1, I'm only counting all the numbers that end with a 4. If that's the case, no pun intended, there's only one choice. How many choices for my second restriction then do I have? If I know that that's a 4, my first number is either a 3 or a 5, and I would have only 2 choices because it can't be a 4 because I've already used up the 4.
So what would happen with the other restriction? Would it just go away?
Well, we haven't counted that yet. And so now there's no restrictions on the middle number. How many numbers do you have left that could go into that space? How many choices do you have left for that space? 3. For 6 ways. What haven't we counted? We counted all the numbers that end with a 4. What we didn't count was all the numbers that end with a 2. That would still make it an even number. But now we would have 3 choices for our first number, because it could be the 4. You've used up 2 digits. How many choices do you have left for your last space? There's 3 digits left. Add them up, and there will be 15 numbers in total using the numbers 1 through 5 that are greater than 300 and even. So we know it's a cases question because we can't count it directly. As soon as we run into a space where you have like, well, it depends, if that's your question that you're going to ask yourself, well, it depends if I pick the 4 or not in my first number, what I can put here for my second number. That's telling you you should break this up into cases. And we broke it up into cases by taking one of our restrictions and separating it. You could have, and you don't have to write this down, but I'll just do it quickly here. Why is it 3, 3, 1 in case 2? Well, in case 2, you ended with a 2, right? Case 1, I mean, our first decision has restrictions as well. It still has to be greater than 300. And you have 3 choices for that, a 3, a 4, or 5. 300s, 400s, 500s. So this is what, these were our numbers to begin with. Okay? When you did the 2, this 2 went away. When you made your first decision, you chose one of these. We don't know which one. So let's say, oh, we'll pick the 5. But that still leaves 3 numbers left. Now, if you hadn't have picked the 5 and you picked the 4, well, you would still have 3 choices left. If you hadn't picked the 4 and you picked the 3, you would still have 3 choices left. So even though there's a 3 in there, you're still only choosing one of those numbers. But it's saying, for example, in your tree diagram, there would be 3 branches going off, each of them the same. And so that's why we multiply in the end, but that's why our choices are still 3 left for the middle number. So there's more than one way to do this question. We did it first by taking our last restriction and breaking it up. Can you see that you could have taken your first restriction and said, I want to start with a 4. I only have one choice then. Then how many choices to make it even? This has to be a 2. So I only have one choice for that one. How many digits are left for our middle number? 3. Only 3 ways. What haven't I counted? I could start with the 3 or the 5. 2 ways of doing that. How many choices would I have for my last digit? Well, it could be the 2 or the 4. 2 choices. I've used up 2 digits. I would have 3 choices left for the middle. That will give me 12. Does it still add up to 15? Yes. Would it have been wrong to say, start with 3, start with 4, start with 5? No, it'll give you the same answer. I could combine 3 and 5 into one case because when I choose 3 and 5 and have 2 and 4 there, notice there's no overlap. So that's why I can count it all at once. But if you had made this into 3 cases, by breaking up your first restriction into 3 separate ones, it would still work out. I like to choose the restriction that has less options because it usually means you're going to get less cases. But you could have done the first digit in 2 cases as well. So this is a type of cases question where you try to count it all at once and you realize there's an overlap of your restrictions. And a last very typical cases question that we're going to do is when they say, we want to use the numbers 1, 2, 3, 4, and 5, and we want it to be greater than 232. So if you did try to do this all at once, there's a restriction on the first digit. What are your possibilities for your first digit? 2, 3, 4, or 5, right? But then if you put a 4 there, you really have no clue what number you could put there. Because if it's a 3, 4, or 5, there's no problem. But if it was the 2, well, you can't have 210 or 215. That's less than 232. So we have a problem. We have a problem with this 2. And then we're going to have a problem later with the 3. So what I like to do with these ones that are greater than is I look at my first case and I say there's a problem with my first restriction on my first digit. What could I do to guarantee that it would be bigger than 232? Well, the problems with the 2, if I start with a 3, a 4, or a 5, my numbers will be in the 300s, the 400s, and the 500s, and they will all be bigger than 232. So if my first digit is a 3, a 4, or a 5, I would have 3 choices there. There would be no restrictions on the other ones. It wouldn't matter what I picked for my other digits. I'm going to be larger than 232. So how many choices do I have left? Again, we were using the numbers 1, 2, 3, 4, and 5. If I chose the 5, I'd have 4 choices left. If I chose the 4, I'd still have 4 choices left. If I chose the 3, I'd still have 4 choices left. So no matter which digit you choose, you would still have 4 choices left. And then you choose another number, how many choices would you have left after that? 3. For 36 in total. Case 2. Start with a 2, but then we're going to have problems with our second digit. So again, what I like to do with these greater than ones is say, well, if I start with a 2, what would guarantee that I'm going to be larger than 232? If I do my second number 4 or 5, then I'll count my numbers in the 240s and 250s, and they'll all be bigger than 232. So I do my 3 spaces. I say I'm going to start with a 2, 1 choice, and then I'm going to do a 4 or a 5, 2 choices, and then it won't matter what my last digit is. And since I have chosen my 2 and either the 4 or the 5, how many choices do I have left? 3. For 6 ways. Case 3, what haven't I counted with? Start with a 2. I have to count my numbers in my 230s. This is a 2, 1 choice. This is a 3, 1 choice. How many choices do I have left for my last one? Do I? Whoa. Let's steal this and bring it back down here. So I've chosen the 2, I've chosen the 3. And this is why with this last one, it's nice to write out your choices, because if you go in your head, you'll say 3, because there's 3, 4, and 5 bigger than 2. Because you want it to be bigger than 232. So the last digit has to be bigger than a 2. Why can't I just go 3, 4, and 5? Because I've used up 3. The only ones that are left that work are 4 and 5. Add all of these together, and there's 44 numbers that are bigger than 232 using the numbers 1, 2, 3, 4, and 5. Of course, the other way you could do this is write every single one out and just count them in the end. But that is very time consuming. So the cases works better. So if we recap everything we've done so far, all the strategies we've learned for permutations, we started with spaces. That was our fundamental counting principle. Within that, we learned the NPR formula, right? If you have 12 desks and 5 students, you could do 12P5, or you could just do 5 decisions. You could just use your spaces and put in your choices. We also learned that if we have a restriction, that we have to deal with that restriction first. If you have an even number, well, then you have to deal with that even number first. We then went on to Mississippi questions, questions with identical objects. Right? We saw that Mississippi questions in Permutations 2, how many ways can you rearrange the 3 red flags, 2 blue flags? Those have identical objects, so you have to decide, do I have identical objects or not? And if it is, then I'm going to have to use my strategy where I first look at how many things there are in total, and then I divide by the identical objects. Sometimes we want things grouped together. Sometimes couples are grouped together. Sometimes different types of, you have objects like my books. They're grouped together by subject. Or you've got certain people wanting to sit together, grouped together by couples. The last thing we looked at today was cases. When you can't count something all together at once, you break it up into cases, and then once you've calculated each of your cases separately, then you add them up to get a total in the end. And throughout all of this, in different places, we've also seen the not strategy. Sometimes it's easier to count the bad situations rather than count the good situations. We saw that in Bill and Jill not wanting to sit together. It was easy to count them sitting together as a grouping strategy, and it was easy to count all of them. So if we do all minus the bad, we get our answer, and that's using the not strategy. So that not strategy comes in. Sometimes you'll get these questions grouped together, right? We had cases questions with restrictions. Sometimes you're going to get a grouping question with cases. You've got the grouping question with the not strategy. So your job when you're working on permutations 3 and 4 is you read a question, and the first thing you sort of have to decipher is which of the following strategies applies to this question? What makes sense? And then you solve that using those strategies. A very bad strategy while working on permutations is to go, I don't know what the answer is, so I'll look at the answer. Oh, it's 24. Well, I can do 24 by doing 6 times 4. So maybe that's how I'll make my strategy. And you make things up to make those numbers work. That usually is disastrous. So come up with a logical way and then check your answer to see if it's right.